Hello students, today we are going to look at simple machines, and one of the simple machine that we are going to look at is a pulley. Now if you have not seen pulley earlier, it's a very simple thing. It's a grooved wheel. The groove is provided so that the cable or a rope or wire can be passed around that and can remain enclosed within the space provided. It is mounted on the shaft, right, and so that it can rotate freely on this shaft. Now if it has multiple pulleys, then it is important that each pulley rotates independently. So if I rotate this one doesn't rotate along with that. So that's the pulley. The experiment that we are going to do today is to demonstrate to you how pulley system makes our life simpler, okay, in terms of how much effort do we have to apply to lift something. How does that happen? So let's look at that. Now the things that we need to do this experiment is a set of weights. That is what we are going to use as load. Obviously pulleys, threads, that is the one which we are going to pass around to lift the load. Spring balance. Now this is the one which is going to be very useful in this experiment, because that is going to tell you how much of the force that we are applying to lift the load. Now it has two parts. If you can see, on one side you have a gram scale and on one side you have a Newton scale. Now it is one and the same, is only the question of units. So when you talk about newtons, we talk about the force, and when we talk about the grams or kgs, we are talking about the mass that is being lifted. But as you know that let's say a 50 gram mass will provide the half 0.5 Newton of force. So that is simple mass into gravity formula, which you are all aware of. Of course, then we need small things like hook, thread, scissor, and the scale. And the scale is also an important thing in this experiment, because we are going to measure how much are we moving load and how much are we moving the effort to move that load. And that's one of the crux of this entire simple machine. So let's start doing that. Now what I'm going to do first is I'm going to measure the weight using this spring balance. So it is roughly 250 grams. Okay. Now I'm lifting this load, and it is also telling me how much Newton force that I'm applying. So it is telling me that I'm using 2.5 newtons of force to lift this. Okay, so that's something that you are already aware of, and we will see now how does it measure if we use a simple pulley. So let me do that setup now. So what I have done here now is that I have just attached this weight to the hook, and the thread is tied to this hook which is passed around the pulley. Now using the spring balance, which I will attach on the other end of this thread, and see how much load do I have to spend to lift this load. Okay, so what is this coming to now? It's coming to slightly more than 250. It is somewhere between 250 and 270, maybe around 275 if I look at, yeah, so somewhere around 275. So my weight was slightly above 270, then I added the hook and then the friction of the pulley. Now that makes it 275. Actually, I am not getting any advantage. I am using as much force which was exerted by this weight, including this hook and this span and everything. I am applying the same amount of effort here to lift this. And look at the distance. I mean, you can make out visually also that as much as this weight is moving, the same amount of distance is traveled by the spring balance as well. So there is actually no advantage. So what is the advantage of this system then? The advantage of this system is that it basically changes the direction. Typically when you are using this kind of a system to change, to let's say draw water from well, instead of using your shoulders to take the water out from the well, you're using your whole body, because the pulley allows you to change the direction from applying the force vertically, it allows you to apply the force horizontally. And if it is too much of a load, you can always use bullocks and any other kind of a machine to pull that thing, but really it doesn't allow you any kind of advantage per se in terms of the force that you have to apply to lift this load. Now let's take a simple example of you and your friend. You have been asked to, let's say, lift the table of something which say weighs around 25 kgs. Okay, 25 kg, and each one of you is not capable of lifting that load, right? So what you do is you stand on one side, and that is all the best I can draw the drawing, and your friend stands on other side of the table, and you, both of you, try to lift this table. It becomes easy for you. And let's say you have to move this table from this position to move it to another, let's say 2 meters. What has happened here is that the distance that you have to travel is 2 meters, the weight that has to go 25 kg. So let's write it down. 25 kgs has to travel 2 meters. Okay. Now I'm assuming that both you and your friend are equally strong, and each one of you share the load, and each one of you is lifting 12.5 kg. So now the effort that you are spending as a single person is only 12.5 kg, and you are traveling 2 meters. But that's not the end of the story. You travel 2 meters, your friend also has to travel 2 meters. So I will multiply that. The same thing has happened in the process twice. Your friend traveled 2 meters lifting 12.5 kgs, you travel 12.5 lifting 12.5 kgs for 2 meters. So it is 50 kg meter, and this was same 50 kg meter. I mean, I'm jumping the gun here, and I'm assuming that you are familiar with this concept of energy and the work done, because energy, what you spend, is proportional to the amount of weight that you have lifted and the distance that you have traveled. So imagine if I have to travel only 1 kg, travel 1 meter lifting 1 kg, vis-a-vis I have to travel 10 meter lifting 1 kg. Obviously it is a 10 times more effort. So you basically multiply the mass or the force that you have to use to lift that mass into the distance that you are traveling. So it is 50 kg. So what happened here is that the load on you has come down from 25 kg to 12.5 kg, but together both of you travel 4 meters. And it's a good trade-off. It's a good trade-off between force that you have to apply and the distance that you need to travel. So let's see if that also works for the pulley. I will do the setup and I will show you. So what I have done in this setup now is that I have attached one end of the string to the hook. I pass it around the pulley. Now this pulley is no longer a fixed pulley like this one earlier. Now it's a movable pulley. Attach a weight to it and it is passed around this pulley. This pulley, as you know, if I use it around, use this pulley, it is not going to offer any advantage. But let's see what does this movable pulley does to the whole thing. So I will again use my spring balance and attach it to the end of the string and see how much do I have to really load that I have to use. So if I look at it, I am using roughly around 190, between 180 and 190 grams of weight, roughly around 2 newtons of force I am applying to lift this load. While we are looking at the load, let's also look at the distance that is for which I have to lift this load. Now let's see, my hand is here, right at the top of the structure, and this weight is at the bottom. So I will put the scale for you to look at and visually try to understand as to what is the relationship between the distance that my hand has to move and the load has to move, this weight has to move. Let's start. Do you see the difference? My hand traveled almost twice the weight moved. Okay, I will do it again. So my hand roughly traveled twice as much as the load moved. Now what has happened here is that while my load, my effort has gone down, but my distance has increased. So what we are doing here with the pulley system is essentially a trade-off between force and the distance. The trade-off that you did in this case, instead of traveling for 2 meters, you travel for 4 meters, 2 meters you, 2 meters your friend, but each one of you only carried 12.5 kgs. So it's a trade-off that you did, and that's what the pulley makes, how the pulley makes the life easier for you. You don't have to use 25 kg. You don't have to use a motor which is going to lift this entire load. But with the set of pulley system, you can actually cut down on the force required, maybe but the longer distance, which is fine, but you don't have to really build those bulky motors to lift the load. The cranes that you see all around you when the construction activity is going on, the metro work is going on, those cranes use this this is called a block and tackle system, the set of fixed pulleys and the movable pulleys. They reduce the amount of effort that is required to lift the load, but at the same time, the effort that they apply to lift it is much longer than the how much is the load moves. So load moves marginally, but the effort, the motor moves quite a bit. Now let's extend this whole thing and say, if we have 2 pulleys, does it make it even better? Let's try that. Now let's look at this configuration. Now what I have done here is that in this configuration is that I still have string attached to the hook tied to this structure, and this time I got 2 pulleys, right? And it goes around this double pulley, comes back, again goes down, and then we kind of let it go. So last time we just had a single wheel or single pulley and we had 2 strings. This time we got double pulley and we got 4 strings. So let's see how much is the force required to lift this load. Okay, so I am seeing here somewhere close to 90 or 100. Somewhere between 90 and 100 is the load required to lift this thing. Now let's look at the distance as well. What is happening with the distance? Is it same as last time? So I will bring a scale, maybe set it up at 10 centimeters and look at my hand. It is at 55 or so. Let's look at how much my hand moves and vis-a-vis how much is the load is moving. Is that ratio also 1:4? What is your observation? I think it will be around 4 because that's how the this mechanism of pulley works. So just to conclude, what we observed here is that pulley system does make life easy by reducing the amount of effort that was required to lift this heavy load. And more strings or more pulleys that we add, it reduces, it gave us more and more advantage, but at the same time it increased the amount of distance that the effort has to move. I have 2 questions for you. Imagine you are sitting in this pan and I give you this end of this string in your hand. Will you be able to lift yourself with this 2 pulley system? My second question is, how many pulleys would you need to lift this load if they say this load is 5,000 kgs? If you know the answer, please write them down in the comment section below. I hope you would have learned something about the pulley system and the advantages that it offers. I have not gone into the depth of using the various terms like mechanical advantage, velocity ratio, that anyway you would have covered in your classroom sessions. So with that, I will conclude this session and see you with another experiment on biology, on physics or on chemistry. It's always good to learn science with some experiment, with some fun going on with that. We are making these videos so that science learning can be fun and enjoyable. If you like our videos, please subscribe and don't forget to press on the bell icon so that you can keep getting the updates about our latest videos and experiments.